Focus कर लो. Okay class, today we will find moment of inertia of rectangular lamina. Okay, so firstly we will see how a rectangular lamina look like. You can see its shape is like a pen, like a page. It is thin. Okay, so this is thin. It has length and breadth. Its length is, let capital L, and its breadth is, let this is B. So, and its mass, let us, its mass is capital M. Okay, here the length we have taken L and the breadth is B. So if you find the area of this lamina, this will be L cross B. Okay, why we are calculating here area? You can see here the mass distribution in this rectangular lamina is over a surface. Okay, so if you find the surface mass density, then it will be total mass of the lamina divided by its area, that is capital L into B, small b. Small b is the width. Okay, now we will find out, we have an axis, let this axis is y dash. It is passing through the center of mass of this lamina and it is in the plane of lamina. If you find the moment of inertia about this axis, then moment of inertia about an axis passing through center of mass and lying in the plane of rectangular lamina or plane of mass distribution, then it will be, here that axis is y axis. So this will be equal to find this, what we will do? We will make use of a trick, and that is we will divide this lamina into elementary surfaces. Okay, let us take the length of this element is dl. Okay, so if we find, and it is at a distance of small l, if we find the moment of inertia of this elementary, what we have done here, we have divided lamina into elementary surfaces, we can say. Okay, of mass dm. Okay, now we have to find this dm, and the dm will be this will be surface mass density into the area of the elementary surface. So the area of this surface, that is ds, it will be, you can see its length is dl and this distance is b. So I can write it b into dl. Simply you can substitute it here, and if you find the moment of inertia of this elementary surface, this will be dm into square of the distance from axis of rotation, which is here small l. Okay, now to find out the total moment of inertia about y axis, which is lying in the plane of rectangular lamina, what you will do, you have to cover the all surface using this elementary surface. So you will start from this end to this end. Okay, Mean to say you have to integrate this relation within the limit minus L by 2 to plus L by 2. Okay. Then you will get the moment of inertia about this axis. So it will be integration of this within the limit minus L by 2 to plus L by 2, and here dm is sigma m into ds, and the area ds here is b into dl. Okay, then you have L square, so it is L square. You can see b and sigma m, these are constant, you can take them out of integral. So here you can put the value of sigma m is m by area of the lamina. So here you will get m divided by capital L into width of the lamina, and then you have b, here you have b, and then you are to integrate L square dl. Okay, so here you will get L square dl minus L by 2 to plus L by 2. Okay class. Now its integration will be L cube by 3, and the limits of integration are minus L by 2 to plus L by 2. So if you substitute this value here, then you will get. So class, after integration you will get this thing. Okay, and after substitution of upper and lower limit, then you will get, this will be L cube by 8 to L cube by 8, and you have here 3. So finally you will get L cube by 12. Okay, and here you see b will cancel, and finally you will get mass of the lamina divided by L, and integration of this is, you can see it will be L cube by 12. Okay, and from here it will cancel. So finally you will get ml square divided by 12. Okay class. Now we are to find the moment of inertia about an axis which is along the length and passing through the center of mass. Okay, let that axis is this one. Okay, this is your x-axis. Okay, you can see this is passing through the center of mass and it is along the length. Y-axis was along the breadth. Now what you will do to find the moment of inertia about this axis which is along the length and passing through the center of mass? You will make change here. The elementary surface you will take now along the length. Okay, this will be the elementary surface, and its thickness you can take dB, and you are to integrate it from minus b by 2 to plus b by 2, and you will get the same result. There will be change, you will get here b square. So the moment of inertia about x-axis, about an axis which is along the length, that will be m b square by 12. Okay, now these two axes, x-axis and y-axis, these are in the plane of mass distribution. What will be the moment of inertia about an axis which is passing through center of mass and perpendicular to plane of mass distribution, or perpendicular to the surface of rectangular lamina? To find that, you will make use of perpendicular axis theorem. Okay, here I am talking of an axis which is perpendicular to the plane of lamina, z-axis. So this will be Iz equal to Ix plus Iy. Why? because you can see x and y, these axes are passing through center of mass, so their sum of moment of inertia about x-axis and y-axis will give you the moment of inertia about an axis which is perpendicular to plane of a rectangular lamina, and that is given by this relation. So Iz here will be equal to, what is Ix? You can see this is Ix and this is Iy. So here you are just to add these, and in these two factors you see m by 12, this is common. So I can take it common, m by 12 into L square plus B square. Okay. So this is how you can find the moment of inertia of rectangular lamina. You can do other cases. If you have an axis which is along the length and passing through the edge, suppose this is the axis, okay, and this axis is AB. So these are the cases. You have seen the moment of, now to find the moment of inertia about the axis AB, you will identify the axis which is passing through center of mass and parallel to this axis. Okay, so the moment of inertia, you will make use of parallel axis theorem to solve such cases. So the moment of inertia about AB, this will be equal to the moment of inertia about an axis which is parallel to this and passing through center of mass, that is x-axis in this case, and plus mass of the lamina, total mass, and then perpendicular distance, square of the perpendicular distance. Here this distance, the breadth of this lamina, that is b. So this distance will be b by 2. So square of b by 2. So in this way you can solve it. And if you have an axis which is passing through the edge, this edge, this is CD. So in this case you can see, again we will make use of parallel axis theorem, and here the perpendicular distance will be L by 2. Okay. So firstly we will identify an axis which is passing through the center of mass, then we will find the distance, okay, and then we will apply parallel axis theorem. So here the moment of inertia about axis CD, this will be equal to the moment of inertia about y-axis, and then plus total mass of rectangular lamina and square of the perpendicular distance, which is L by 2 in this case, square of the perpendicular distance. Okay, after substituting the value of I, y, you can find it. Okay, let us do one more case. If we have an axis which is passing through mid of the breadth and here, and perpendicular to the plane of lamina, C and AB and CD, these axes are in the plane of lamina. Now I am taking an axis which is passing through the mid of breadth and perpendicular to plane of lamina. Then you can see this axis is passing from this point, and z-axis is perpendicular to this surface and passing through center of mass. So this axis will be parallel to z-axis, which is passing through center of mass. So again you will make use of a parallel axis theorem to find the moment of inertia about this axis, and let this axis is Mn. So the moment of inertia about Mn, this will be equal to moment of inertia about an axis which is parallel to Mn axis and passing through center of mass, that is z-axis in this case, then plus mass of the rectangular lamina, and this perpendicular distance here is L by 2, square of L by 2. So in this way you can find. Okay, and if this axis is at this corner, then this distance will be, you are to find this is L by 2 and this is B by 2. So this is hypotenuse in this triangle. So it will be, this distance will be, let this is D. Okay, let me take one more axis and this is M dash, N dash. So the moment of inertia about M dash, N dash, this will be equal to Iz, because this is also parallel to Z axis and perpendicular to surface area of the rectangular lamina, but this distance has changed here. Okay, so it will be Iz plus mass of the lamina, that is M, and square of distance D. I am writing it D square. Okay, and what will be D? D is under the root. You can make use of Pythagoras Prameya theorem, and this is L by 2 and this is B by 2. So it will be L square by 4 plus B square by 4, and you can substitute its value here. So thanks for watching the lecture.